will form. You just need to put the plots that to actually just define the plots that will be like on the top row and the one which will be at the bottom. So the one which will be at the bottom is actually just defined by using this /, then a plot3. So once you do this, Patchwork will actually take over the work and plot them for you. And from a previous slide, this is actually what we want to achieve. You can have this plot1, plot2, then plot3. So what you actually need to do, you just call either Cowplot, GridExtra, and also Patchwork, and you see how they actually do the plotting for you. So this is part of, you will have to install Patchwork in your art studio. So either you can use Pacman, or you can just install during the other ways that we have seen. Just install the Patchwork package. This is how you can actually call for the syntax. But remember, it is easier that the different plots that you have, you just assign them names. Okay, that's just how we use Patchwork, and we'll see this just shortly. Using the same code that you're seeing right now. Then there's also another one which is called Cowplot. Cowplot, assuming that we still have the same three plots. We have plot1, plot2, and plot3. Cowplot, now what you need to do, you need to call the function plot grid. Okay, and when you're calling plot grid, there is actually an option. There's an option for you to also give labels for the rows, or and also you can define the number of columns that you want. So this actually enables you to like in this case, you'll have plot1, plot2, then you just have you want them to be just one column. Okay, you can add also plot3 there, and you can also add another label for that plot, and etc. So these are just part of the options that you can use when you're using the Cowplot. And the syntax, you have to call it you have to call plot grid, and the arguments which come into that plot grid function will be plot1, plot2, plot3, and etc. Then next is what we call the GridExtra. It's also another package that can be used to actually combine these plots for easier comparison analysis. So GridExtra, assuming that we still have the same three plots. So what actually happens, the way you actually, the syntax of using gridplot is the arguments which will be there will be the names given for these plots and the number of columns that you intend to have. Okay, this now will ensure that even if you have an odd number of plots, but as long as you've actually you have defined, or you've declared the number of columns that you want is 2, it will just plot it the way it is. So it plot1, plot2, then plot3 below. But it will have to follow that. You have declared that you want just 2 columns. So GridExtra, we call it using the grid arrange. Then Cowplot, we need to call it using the plot grid, and finally shortly, sorry, and then Patchwork, you just need to actually define how you want the plots to look like. Okay, we'll just look at this shortly, but before we even go to our R studio, there's also another type of visualization that we can also look at, which is called Sankey or Alluvial diagram. So I know most of you may have seen this. This is a type of visualization whereby you can use flow arrows to actually show how quantities are transferred from one set of category to the another. Okay, And this is where the width of the arrows is actually proportional to the flow of magnitude. So you can see, like in this chart that we have here, since you're saying that the width of the arrows is actually proportional to the flow magnitude, you can see like on our left side, what's contributing so much to the budget is actually the wages. Then the other, because the magnitude is small, then you can see that the connecting arrow is also smaller. Okay. On the other side, you can see that from the budget, this can be either be a household budget for family. So you can see that things like other necessities, because the proportion is small, then you can see that the arrow is also small. It seems like for this family, taxes were consuming so much from their budget. So this is just also another kind of a solution that we can also do in R. That is always helpful to actually derive insights from a complicated data set. This is something that we can do an example today. Then as far as Sankey diagrams are concerned, we need to have actually it has 4 main components, and these components are what we call nodes. We need to have nodes. That is the origin, or this is the origin or the termination point of the flow, of a flow. Then you also have to have links. What are you linking these nodes to? So this is actually the connection between the nodes, that which is represented by the arrows. Then you can also have the width proportional to the amount or the quantity of the flow. Then you can also have colors that is used to differentiate different types of flow. And as we will see much later, is that for the component number 4, colors, you can choose actually to have user-defined colors that will be used in this Sankey plot. So the diagrams, so these diagrams actually use nodes for source and target states. So in as much as you have the data, you also have, before even plotting, you must know which data point or which data set or which data component will be the source and what will be the target states. Okay. Then there will be links between them. So we'll do what is called matching. You have to match the source and the targets so that you can be able to actually depict that flow. Then so and we say that they are actually valuable in visualizing complex material. It can be energy, it can be financial, it can be if you want to change, if you want to look at like in our data set, if you'd like to change, if you want to look at the treatment outcomes from a given hospital, what is the age group that was proceeding to this type of care, you can easily use Sankey diagram. Or how many does this hospital receive so many people than this other one? Those ones can easily be visualized using a Sankey diagram. Then so how it definitely works. The thing is, you have to identify the sources and targets. So you have to identify the origin, and as in you just have to identify what you want to connect with what. Okay, and that having that in mind, that can give you an idea of what the source and destination of the flows that you want to visualize. Number 2, you'll also have to specify for each flow, you have to specify the source and the targets and the magnitudes. Then you'll also have to arrange the you also have to need to know which one is a node and which one is a link. Okay, and these links actually form part of the flow between these nodes. Okay, so as I said, the additional detail like number 4, that is the colors, the labels, and other styling can be applied to these nodes and links by the user. But if your nodes are not that many, R will just assign colors to this. Okay, but we will see that also that in our experiment. But if these nodes are so many, we'll find that at one point it will just give them a gray color. Okay, which cannot be useful. So that's why at that point, the user will have to define the color scale or the type of color styling that may be good. Okay, so let me stop sharing my slide at the moment. So let's go to our R environment. So up to last time, let me share my screen. Up to our last class, what had actually happened, we had reached adding aesthetics using the theme function, where we saw that how do you add limits, and the reason why using the code Cartesian function for limit is important, because we said that the other one actually eliminates or cuts off some of the data points, and we also saw how the user can actually take control of some of the aesthetics that are in a given visualization. So we saw all this, how you can actually define the color, the type of font that you want to use, the size, the position of the legend, the size of the text, and we saw that there are so many options that actually come under the theme function, which you can always try and play around, because this is for those who actually write manuscripts. You'll find that a given journal may dictate that they want these fonts in this type. They want the color to be this size, the family of the font to be this and this and all that. So that you can easily do that in the theme environment. Okay, and as always, if you put a question mark and the name of the function and you search, I will just give you the options that exist for that particular function. So what I've actually done, so from the slides, I wanted us to look at how Patchwork works, how Cowplot works, and how GridExtra works. So and this is we're just building on what we have been using. So I will run this so that we have our data is as we want it to be up to there. So the rest of the plots, we may not really need them because it's something that we have already done. But I can just plot this one where we added more aesthetics last week so that we see how it looks like. You can see you can just take control of everything in that visualization. But now, coming to Patchwork, so this is where I was defining that I was doing this. This is the first plot, and the first plot you can see is just a box plot, of which, remember, as we said, that ggplot is actually a layered visualization. So I have the box plot, then I have the jitter. The color of the jitter is blue with transparency of 0.3, okay, and the notch is true and all that. So the color is actually defined by the HIV gender, and you can see there's that legend there, which is female and male. Then and please, if you have any questions, please post it in the chat. My colleague Ashna and Chioma will also assist in answering, but you can also figure them out together. So if anyone does not know how we are coming up with these plots, please feel free to post your questions in the chat. Then my second plot was so you can also have a scatter plot for this one, and this one was just for CD4 count versus the variable. We're still using the same data set. Then and you can see for the color. So this one now, it was a static color whereby we were defining the color of the points to be forest green. So we say that this can also be achieved if you assign a column value, whereby like in line 179 for the box plot, you can also use you can always use a column value. Then our other plot was a histogram. Again, For the histogram, you can see the fill was just green. The color outline of the bars was black, and the bin width was about 10. Okay, so those are the three plots, and you can see I've actually assigned the plot 1 to be the first plot, then plot 2 to be the geom or the scatter plot, then plot 3 to be the histogram. And you can see in my environment on the right hand side, all of them have and you can see in my environment, all the plots have appeared. Now, because for the first part, since we are using a patchwork, so you can also ensure that you have also loaded patchwork. And you see, let's see how this combined plot will look like, because it's just in plot 1, then followed by plot 2. But below these two plots, you want plot 3 to be there. Okay, that's a very simple syntax to call. So if I do this, let me just run this again. Okay, I don't know if I'm getting the error. Server error. Let me run this again. Or rather, let me just run everything from the top again. I do not want to do that, but so let's see shortly how that actually looks like. You see now. So what has actually happened? You can see in your plots, in our plots pane on our bottom right, what has actually happened? It has this is oh,
I think this one might be the Cowplot, it looks like.
yeah, this is actually the Cowplot. Why is this one not running? It is geom point. I've loaded Patchwork.
And from here, maybe just try printing combined plot.
Oh yeah. Oh yeah. Thank you, Ashna.
No problem, no problem.
I had to call the combined plot, yeah.
There it is.
Thank you. Yeah, so you can see now for the patchwork, we have plot 1, which is the box and the jitter. Then plot number 2, which we had done the scatter plot, actually takes the second position. But now, because we have said that plot number 3 will actually be below these two, then you can see that now the histogram comes below the two plots. Just for argument's sake, let us change this plot 3 to come here. Then plot 1 to actually come here. Then we see what actually happens in this case. Then you need to run something. Yeah, so you can see now in this case, the order has actually changed. So now, because we have defined that plot 3 will take the first position, then you have the histogram. Plot 2 is the scatter plot, so it still remains the same position. But now plot 1, because now plot 1 is the only thing come below the 2, then you have now the box and the jitter below. So that's just one of the plots that, or one of the ways that we can combine different kinds of charts into a given into the same figure. So plot 1, plot 2, and plot 3. Okay. Then let's see. I don't know whether this will work, but I've not tried it, but let's see. Suppose we also have this plot here. This is yeah, this is the one. Let us copy this one and add it here and call it maybe plot 4. Plot 4. So that whatever happens there, we can also have maybe plot 4, which is defined there like that. Okay. So let's see whether now we'll have plot 3, plot 2 on top of it, then plot 4, plot 1 below. This now will be the new combined, should be the new combined plot. Then the combined plot, how does it look like? Yeah, so you can see now, in case you have an extra plot, you can still come and actually add it here. Then again, I just want to make this even more messy. Let us also have another plot, which is we can call it let's just call it plot number 5, so that we have plot 5. So we also have it there as well. But that is plot number 5. So let us also add it here, so that plot number 5 is in the first row, and we see how will this look like. I know it may become even more cluttered, but let's see what it looks like. Take some time. Yes. So you can see now after actually adding plot number 5 and positioning it in the top row, we can see that so it becomes plot 3, plot 2, plot 5, what we have here. And you can see, and the beauty of combining these plots, you can now define different labels for each different chart. Like the one here, this plot number 5, you can see it has loaded it with its own axis. And you also notice that this plot number 5 is also actually a facet plot, whereby it has plotted the according to the gender, that is the female and the male. So this combination actually works well. For example, for those who are in the medical field and you would like to write maybe something like a policy brief, and a policy brief in most cases they're supposed to be a 1-pager or at most 2 pages. You can always consider using this kind of combined plots, so that you can save on space, and it's also better for comparison or comparative analysis. Okay, so that is on Patchwork. Then the same thing will also oh, I can see there's a question in the chat. And Milola is asking, for some reason, my RStudio says it could not find the function geomgita. I can see Ashton has answered. Damilola, have you tried loading ggplot2 in your environment?
Yes, I have, but it's loaded, but I'm not seeing the plots in my plot section. It's not displaying what I plotted.
Okay, can you are you in a position to share your screen?
Yes, I am. Let me see.
Stop sharing. You can share.
Can you see my screen?
Ah, I see. So have you selected from line just select for assuming that Patchwork is loaded, just select from line 227 up to the end of 229. Select that and run it.
Yes, I've done. Just keeps on showing on my console, but nothing is being plotted.
Okay, I see. So what you'll actually do, then do you see that line 227 where you have plot 1?
Yes.
I would like you to select just that plot 1 and run it. Just that plot 1. Just the name of plot 1, then you run it. Just the word plot 1.
Okay, just the word plot 1. Okay.
Just run that one.
It's still not working. Okay, it worked. Thank you.
Yeah. So what it actually meant is that you assigned a plot 1 to that visualization. And if you can see in your environment, plot 1 actually appears. Okay.
Yes.
So
Yes.
you can either select plot 1 and run it, or you can just after the plot, you can just say print plot 1.
Oh, okay.
Then
Thank you so much.
welcome.
How do I stop? Okay.
Okay. Let me let's go back to this. So so now okay. So now we can look at how that was for Patchwork, and I always find Patchwork to be a bit easy to work with, because once you've actually loaded Patchwork, all you need to do is just need to define the order of the plots that you want. Okay. So we also have Cowplot. Cowplot will still use the same plots that we had, plot 1, plot 1, plot 3. But for us to actually combine to plot the grid, you can just let us also add plot 3 here. A comma. You want a label for this. Let us leave it for now, but we'll still add it again. So let's see how Cowplot will look like. So what has actually happened here is that for Cowplot, that is line 212 up to 231, what has actually happened is that remember, we have the plot grid, and for the plot grid, we have defined that we want to plot 1, plot 2, and plot 3. And the labels is just A and B. So what this will do, it will automatically label according to the order of the plots. So in this case, it will just label plot 1 as A, as you can see in this chart here. Then plot 2 as B. But most importantly is the n call, the number of columns. In this case, what we have, the number of columns equals to 1. And you can see all of them have been plotted in one column. Suppose we change this to 3 and we see what happens. So at least for 3, I expect something to look like a facet using the facets. Yeah, you can see now you have A, B, and the other one. Okay. So calls depends, and suppose we use 2, we have 3 plots, but we just use 2, just for argument's sake. We see what will actually happen. So what will actually happen, it will just plot plot 1, plot 2. It will continue apportioning these plots according to the number of columns which have been defined. So in this case, the n call was equals to 2. Okay. So as simple as that. So you have plot 1, plot 2, plot 3. And so in this case, let us also add our, because you have 3 plots, let us also add another label there, so that so that all the plots now have labels A, B, and C. Okay. So there's a question in the chat. If you do a plot grid, plot 1, plot 2. Oh,
Yeah,
okay.
that's just me musing in the chat.
Okay, okay, wonderful. Yeah, this is another good suggestion that you can do. Then let's Ashna, let us actually do that.
Sure.
Let's see, plot 1, plot 2. Then you can have the rel width. Sorry. One. And we see. Oh, that's not supposed to be there. It's supposed to be there. Labels, number of columns. Okay. Or rather, let's do this. Let's start first of all. Just the way it is. Then we see how this one will look like. So that one was then plot 1, plot 2. So the width will be 2 and 1. So plot 1 will be twice as wide as plot 2. Okay. Ashna, could you explain that for us further?
Sure. So I think this one you might have to put, I think, rel width. So just add an S at the end of rel width.
Value width, yes. Width, okay.
Yeah. And then I wonder if since there's 3 plots, I wonder if we have to supply 3 numbers instead of just 2.
So I have 3 here. Like that.
No, as in, because C21 basically makes plot 1 twice as large as plot 2. So I wonder if we should do like 2, 1, 1 maybe. So then plot 1 will be twice as large, but plot 2 and 3 will be half as large.
Okay, okay. So let's say so plot 1 will be twice as large as plot 2. Wonderful.
Yeah, there you go.
Great. Yeah. So and if we do a 3, it means that it will just be 3 times wider.
Mm.
And, yeah, great.
There we go.
Yeah, that's also another option that we can do that you can actually use. So that is more options under the Cowplot. You can actually change the width of each plot. Then so the final one is GridExtra. Again, we'll still use our 3 plots, and for this one, the syntax to it is grid.arrange, then plot 1, plot 2, plot 3. Then you just define you define the number of columns. So in this case, number of columns is 2. Let's see what actually happens to that. Yeah, so it's just the same thing. Ashna, do you remember whether we have any other additional options for grid arrange?
Not that I know of. I think you can use specify a number of rows as well in addition to number of columns. I guess that only really makes sense if you have lots of plots.
Grid arrange. Okay. So you can actually also define the number of rows and columns. This is a GridExtra. Yeah, so you can always check the number, the additional options that exist when it comes to this functions that we are using. But I believe if you have, let's see, let's go back to this plot and carry the two of them. We also have them here. And you see plot 1, plot 2, plot 3. I want to have this plot a bit messy. Plot 5. Let's have 5 columns. Let's see how this one looks like. A comma. So this will be so at least it because we've defined 5 plots and we've defined that the number of columns should be 5. Plot 1, plot 2, plot 4. Oh, the others are still being plotted. Yeah, but I think it will depend with how tidy you want your visualizations to be. But basically, that is how you can actually plot different types of. You can actually combine different types of plots into one chart. And as I said, this is just useful when it comes to comparison. But if you have this data visualization of the same type, you can consider using a facet trap or facet grid, because those ones have already built in orderly way or sizing of the graphs that make those charts more aesthetically appealing. But if you have different kind of plots for different types of geometry, you can always use GridExtra, Cowplot, or Patchwork to actually combine all those plots. So up to there, I don't know whether there is any question. Any question you would like to ask? Okay. If not, I think we can quickly go through an example of a Sankey diagram, or what some people call alluvial diagrams, and we see from the same data, can that plot give us any meaningful results or information? So for that matter, please install these 2 packages. Okay, I know you already have tidyverse, so you can actually just call. You can actually load tidyverse into your environment. Then you can also install network D3. Network D3 is the package that we'll use for our Sankey diagram. So you can use Pacman, payload, then you can put the 2. So network D3 and tidyverse. Okay. So but remember, as we said in the definition of the Sankey diagrams, is that the critical thing is to, first of all, you need to define the nodes that you want to use, and you also need to define the links, okay? And how the nodes and the links will be, how the nodes of the link will actually connect with one another. Then you can be able to do that Sankey diagram. So our data in this case, so for this Sankey plot, we would like to link. Let me just so in this case, we would like to link hospital of diagnosis from our data, hospital diagnosis, and the age category. So do we have any specific hospital that are given age or the population actually likes to go? Okay, we can actually do that, and because if you look at our data, if you look at our data, we have the age, we have the gender, but from our previous sessions, we had added some modification whereby we had added the HIV category, the HIV gender, and we also added the age category. We also have the type of case management. We also have the type of diagnosis that these patients actually went to, and we also have the hospital of diagnosis. Hospital of diagnosis, you can see there are so many, but we'll see how we can work around that. So the first thing will be, because we are really interested in just looking at the hospital of diagnosis and the age category, from what Ludovic and Ashna taught us, we can actually select just those two columns and work with them. Okay, so I can decide. I can now call this. I can just derive that data from these two. So HIV data, I can call it HIV data 2. And what I want to do, this will be my HIV data. But what I want to do, I want, first of all, to select. I would like to select, what do I want to select? I want to select the hospital of diagnosis, because that is of interest to me. Then I can also select the age category. Okay, so that for the data that you will be working with, that is the HIV data 2, you don't have to use the whole data set. You just actually select what is of interest to us. Then just because Sankey diagrams actually behave in a funny way when you have numbers missing. And remember, from our data set, we have some missing values because of how the data is structured. The data set is structured. So we can also we can drop NA, and in particular, we would like to drop this NA for the age category. For the age category, we want to drop this NS. Then let us run this, and you see how this data set looks like. So at least for now, HIV data 2, this is how it looks like. So we just have the hospital of diagnosis, and we also have the age category, which is a factor. So, but now you can see that the next thing that we need to do, because we have dropped, if there are any missing values, those ones we have already dropped them. The next thing we can actually do, we can also count the hospitals and the age category. So we can count. In this case, I want to count the hospital of diagnosis and the age category. Okay. Now, and so let's see. Because now we're actually just working with these two columns. We want to form a connection between these two. So you can see that now, like, okay, let me just increase my screen here. So you can see after doing the count here, you can see like Bomet County Referral Hospital, those people who are of age 25 to 49, they were just about 5. Then Bomet District Hospital, those were 0 to 14, there was only 1 person. 50 to 59, they were about 3. So what it has done, we've actually just accounted for us those different age groups for specific hospitals. Okay, and that's what actually what we want, because now this end that you see, these numbers that we see here, the 531, these ones are the ones which will define the flow or the proportion of the arrows that link the age category and the hospital of diagnosis. So that is important. Then the next thing now, you can name it whichever way that you want, but I think it's important that because we need to have what the source and what the target is, we can ensure that we can rename. So we want to have something which is called the source, and this source will be our hospital of diagnosis. Okay. Then the other thing that we want to do, we also need to create a target, and this target will be our age category. Okay, because now what we want to do, we want to, on our left-hand side, we have the hospitals of diagnosis, and on the right-hand side, what we have will be the target, or rather the age categories. Okay, and so far we know we have around 5 age categories, so we'll expect that even if you have so many number of hospitals on the left-hand side, on the right-hand side, we'll just have about 5 age categories. So we have done that. So what we've done, we've actually also created, let's run this and you see what is happening. So what we have here, you can see in my console, what I've done. So we also renamed, okay, we have renamed the hospital of diagnosis to be the source. You can see here to be the source, and the age category to be the target, and then N, it will just remain. And that is the important ingredients that we need at the moment. So now, the next step is now we want to create the nodes. Okay, we create the nodes, and we see what actually happens. So you can say that how do we create the nodes? The nodes are actually just 2. The nodes will be the source, and the nodes will be the target. These are our nodes. The source and the target, those are our nodes. Okay, but we need to know how we will actually link these nodes together. So in this case, I can just pass them as a data frame, and what do you want to name these nodes? So you can say name equals to. I would like first of all to name as character, because I actually want this to be names. Okay, I want this as character. What do I want as character? I want the name source to be a character, or whatever values are under source, that source column to be characters. So I can say HIV data2, because that's the data set that we're dealing with. Then I can just use the dollar sign to actually get that. Okay, so it means that in this data frame, I just want to have the source to be as character. Then next we'll also have as character, what do we want as character? Also the target. We just want also the target to be as character. So HIV data2, sorry, that is the target as character. Okay, then let's see, are these brackets of this, so you have this one, opening the data frame. So let's see, this one is okay. Oh, I need one more here, but that's for the data frame. But I also want to do something else. I also want to use unique, so that it will name for me. This one is very important, because you can see there are some hospitals that will have been repeated. So you just want to the unique ones. So let's see how this data frame actually looks like, the one that we have for the nodes. So yes, so now everything now is in terms of characters. Then now the next stage now is actually also a very important step. It's now to match, or now we're just trying now to link the source and the name. You see the names that we have, that you have created in line 280. That is for the source And for the target, we now want to link them, or rather match them with what is in the data set. Now, what we can do in this case, in our HIV data 2, we can create a column that is called ID. So we don't want to actually mess with the data which is there already. So we can call this ID. So what this does in line 283, in our data set HIV data 2, it has created a column which is called the ID source. And this ID source, we just want to match it. We want to match it with what? We want to match it with HIV. Actually, you just come to realize that the Sankey diagram is just a lot of labeling and changing the class of the variables that you have there. So HIV source, I want to match it with that. Then I also wanted to match it with the nodes. Whatever it's in the nodes, I want it to. And what do I want to access in the nodes? The nodes just has only the name. So I want to match it with that one. Then the rest, we can also do HIV data 2. Sorry. HIV, I can just copy paste, but it's okay. I also want to create another column, which is called ID target, like that. And this column, I will just match. I would like to match HIV data 2 and what I want to access the target. And what do I want to match it with? I also want to match it with the characters. That is the nodes name. Okay. Let's now run this and we see what actually happens. So you'll find that now my HIV dataset now will have additional columns. That is the ID source and the ID target. Okay. But yeah, let's see. Then I think that's all that we need at the moment. We have created our source and our target and our way. This match actually links these two. So the next thing is not actually just plotting. Let's now plot and you see. I can, because it's a Sankey plot, so what we do, let us just call this, what did you have the other plots? The number was plot 5. Let's call this plot 6. At this plot 6, we can call it a Sankey. What we call a Sankey network. Because now, remember that package I asked you to install, that is network D3. That is what actually carries the Sankey network that we need for plotting. So, in a Sankey network, if you see this prompt or this suggestion in yellow, you can see that the first element has to be the links, has to be, you must have the nodes, you must have the target and all those. Okay, you can now define them. So our links, in this case, our links will be created from the HIV data 2, because that's where the links will come from. Then the next thing will be the nodes. You need to have the nodes, and the nodes, we've already created it in line 280. That will be the node. Then the other one, we also need to define our source, and the source has already been created in our data, this one here. So we can just, because it's a string now, we have to call it. We have to encapsulate it in this ID source. Okay. Then what is our target? Our target is, we can just have it as ID, a target, because we need to call, these are actually names of those columns. So we need to encapsulate them in quotation marks. Then what is the value? Now the value is key because the value now defines the size of that arrow or the size of that link between the source and the target. So in this case, it will be this n. Do you see this n here in the console? That becomes the our size. So now again, we call it that. Then what is the node ID? Node ID, that becomes the again the node that that is the node ID. The node ID becomes the name. This is from this one here, this data set here, the link. It becomes this one here. Let me just show you just quickly. Becomes this one here, the name. That becomes the node name. Then and finally, actually it has so many in this case, let's see, you can use T, the H. This is a unit that is used, is a unit of energy because Sankey networks were previously used for in energy. So let's see what this plot gives us. It's just a simple plot, but you realize that we have so many hospitals in our data set. I know it will look like a funny plot, but we'll see. Let me just clear those plots first because we need to see how that one will look like. Then, so if I run this now, plot 6, converting node cannot get the name. Converting a plain data frame. Okay. I'll just explain this shortly. Why we need to subtract 1 there. Object node. Nodes, not node. Okay, nodes. Let's see. Yeah, so you can see plot 6 has appeared here, but it will be a funny plot because all the hospitals are so many. I don't know. Can you see on my right hand side how it looks like? And we can, because so now you can open it as a web page. So let me just save it on my desktop. Then I can okay, is the question in the chat? Aishna is saying this is art. Yeah, it is. Let me share the outcome of that plot because you can save it as a HTML or you can also save it as a PDF if you want to put it in a. Now, this is actually what I was talking about. You can see that the number of hospitals are so many in that you've actually maybe even gone beyond the color palettes which are available in R. But just for argument's sake, let us reduce the number, just the number of hospitals, and we see how this plot will look like. Because now we are plotting so many, we're actually plotting all the hospitals in our data set which had entries from 1 up to 1,500. So let us just do that together, because now what I would like to do, I would like to reduce, because remember from line 273 we were calling the whole data set. Let me just call a portion of it, maybe from row 1 up to something like maybe row 40, and we want all the columns. Okay, just let us just do it that way, so that HIV data set 2 will actually just have about 40 rows, so that we can be able to visualize how that will look like. Then Let's run it once again. And we see. So in the environment, okay, let me first of all close this one. Close. Oh, no. In the environment, plot 6 is there. So let's see how now it looks like. It is now much better, because now, and you can see what I was talking about is that because on the left hand side we will have the hospitals, and the right hand side we will have the age groups. And remember from our data set, the age groups which were there were just 5. Okay, so now because we have now tried to just use hospitals from 1 up to from the list from 1 up to 40, you can now see the colors are appearing. Like you can see that for Bomet Sub-County Hospital, it had the reason why you're actually seeing like these arrows are almost similar is because the numbers were actually so low, because we were seeing a number like 5, 3, 4, and 80. So these ones are very close. You cannot actually see them with your naked eye unless you zoom in. But if the number of the number of patients in each age group was actually varying significantly from the different hospitals, we're likely to see that the size of these arrows will actually, I can see like this Bomet Sub-County, this arrow is a bit smaller. The size is a bit smaller than the one we have for Kakamega Hospital, for example, down here. Okay, but ideally, this one just gives you the idea of how. So a hospital like Elgeyo Marakwet, this one here, the one in orange here, Elgeyo Marakwet Health Center, you can see it had a number of people who were in the age group 25 to 49, and it also had a number of people who are 60 and above. But in the same county, the same area, you may be asking yourself, where did the other age groups go? So those ones you can see that in Elgeyo Marakwet County, it's a different hospital, county referral hospital. It also had people who are 15 to 24. So what you can actually do further so that this can be one can understand this better, you can now try to add another target here, and this target here will be the type of diagnosis, okay, or the type of treatment that this person was seeking in this hospital. So you may find that the people who are attending Elgeyo Marakwet Health Center, they were just there for a checkup. But those who are going to a county referral hospital, maybe those are also going for inpatient services. Okay, so adding another source and target that can bring out more information using a Sankey plot. But this is basically how a Sankey plot is supposed to be done. Just for practice, you can try. Let's see how HIV data looks like. Just for practice, maybe let me just do this. For practice, you can try. For practice, you can try maybe hospital diagnosis and the comorbidities, for example. And this one will give you a good practice because some of them has to be separated. And there was a technique Ashna showed us how you can separate these elements in this data entry. That will be a very good practice you can try. Then you can also look at type of diagnosis and hospital. So instead of looking now at hospital and age group, you can now try to look at hospital and type of diagnosis, or maybe a type of diagnosis. Hospital and type of management. Then in our other session, what we'll do, we'll now try to link up at least having about 2 targets, which now we in that case we will combine hospital of diagnosis. We'll also combine age group. We'll also combine type of diagnosis, also type of case management. I think that will be a very good exercise in our next session that will inform better how these hospitals are handling, or rather the numbers that these hospitals will actually handle. So I would like to stop there for today, unless there's any question. So that is a Sankey plot for you. I don't know whether you are able to follow through as I was doing this, but that is how the Sankey plot looks like. But the key idea is to try and identify, share the. Okay. So Frank, what I'll do, because from this part, you already have up to this part here.
Yes.
From line 1 up to line 175, you already have. I'll just share the rest from line 177 up to the end. Okay, because that will cover the combination of the plots and also the introduction to doing a Sankey plot.
Thank you.
Okay. Otherwise, if there's no other question, so please make sure that you just play around with those categories of data. Just try to look at what is possible with the data that you have. And the thing is, as you have noticed now, we are now building on the concepts that we have already done. Okay, issues to do with the data manipulation, how we select just a given portion of the data set that we want to use. How do you do the count? How do you rename the columns and etc.? So we're just building on those concepts. Okay, and if there's anything that you have not understood from the previous sessions, please just go through them, and you can always contact us in case of any challenge.
Online 285. I don't know if you explained why you deducted 1.
I deducted 1. Okay. That's a very good question. Let us let me just remove 1, because what I wanted us to do is just some manipulation whereby I wanted. Sorry. You see, this one moves from 0, 1, 2, 3 up to 39. Is it? When I subtract 1, let's see how that looks like. When I subtract 1, that now starts from is it negative? Actually, let's see. It's just some manipulation to change the indices, so that I make sure that I start from 1. But it seems like that is actually not necessary. We can so let's see. Let's see what. Still converting. Let me see. Let's see how it plots, because what I actually wanted to do is, because I just wanted to ensure that the indices of the ID source it is the same as the one in the nodes, because if you have the index of the source starting at 0, then the one for ID source starting at 1, then it can be a problem. So I was just subtracting 1 to ensure that both of them start from the same index. Okay. And you can see maybe it is the reason why it is not plotting, because yes, it is actually missing it, because if I do this, let's just, forgive me a sec, let's do this. This one now, you see, starts from 0, and if I do not subtract that one, what is happening is that this one also, when I subtract 1, it starts from 0, but if I do not subtract 1, it starts from 1, while the source starts from 0. So it's just a way to actually ensure that the ID source and what I have in the nodes, both of them actually start from the same index, 0 and 0. Is that okay, Peace?
Yes, thank you very much. Makes sense.
Okay, thank you so much. And I think please continue practicing. Then we'll meet next week for the Art for Fun club session. So maybe I hand it over to Virginia. Virginia, are you around? Or Ashna, is there anything else you would like to add?
Nothing from my end. I actually learned how to create a Sankey plot using R today. I've never done that before, so thank you.
Yeah, welcome. Thank you so much.
Yeah, so Duncan, sorry.
Mhm.
Thank you. It was a very great session, and I see we have other new names. But for all of you, if it's your first time to join this, it's a session that you do every Thursday, same time. For East African time, it's 7 p.m. to 8:30 p.m. So I sent a message whereby you can see other previous sessions through our digital platform at Afredac through www.afredac.net, whereby you can register and then you can take the course. There is a basic and an intermediate one. So you can see other previous sessions and then you can be taking the quizzes. And then at the end of the day, you can be earning your certificate. So as per next week, I think we'll be having the practical session through what Duncan took us through today. So thank you very much, Duncan, Ashna, Chioma, our facilitators. It was a very great session. We really appreciate. Thank you all.
Okay, thank you all. See you next week.